Hey, ladies and gentlemen, welcome back to Anatomy and Physiology. Today, that's better. We are going to be talking about the skeletal system. Before we jump into our vocab words, I want to give you a little Latin word first. Not one of your vocab words, though. This word is os. O-S, os. That is Latin for bones. So whenever you see os in a word, you know we are going to be talking about bones somehow. For instance, ossification means to make bones. Uh, Osteon is actually a piece of bone. Osteocyte is a bone cell. Osteoporosis is going to be a bone disorder. So anytime you have os in a word, you automatically know bones. So let's jump into our vocab words and see what we got to work with. Starting off is a word I already said, ossification. The process of bone formation, to create bones. That's right, to ossify, to make bones. So here we see a little picture of bones forming. Down here, it starts off as cartilage. That's what this says. Using hyaline cartilage. We learned this word back in chapter 2. Yes, chapter 2, tissues, where hyaline cartilage was that hard cartilage, and that's what fetal bones are going to be made out of. And as that fetus in the mother's womb grows, the cartilage slowly gets replaced with bone material. That is the formation of bones, ossification. Once you get bones, we're going to have two basic variety of bones. We call them intramembranous bone and endochondral bone. Remember these words, guys. There's no real trick to memorizing them. That's just, you just have to study and memorize this. In previous years, these are words that people have gotten mixed up very easily. Intramembranous bones, broad, flat bones, like the bones of your skull or your scapula, that form from membrane-like layers of connective tissue. There we go. You look at the skull, you see all these cracks in it. That's because they're not cracks, they are fusion points, because your skull is actually a bunch of smaller bones fused together. And each one of these smaller chunks of bone, back when they were just a piece of cartilage, they were actually many layers of very thin cartilage, membrane-like layers. That's why it's called intramembranous. And then as they became solid bone during ossification, they fused together. So any kind of bone in your body that's going to be a flat-ish disc. Not to be confused with endochondral bones, which are going to be the long, skinny bones of your body, like in your arms and forearms and thighs and legs. Oh, not your ribs, though. Let's get rid of the rib. Turns out your ribs are not endochondral. Yeah, they look long and skinny, right? No, they're not long. They're wide. That's right. They are actually formed the same way as these bones. So your ribs are actually intramembranous. So we are not going to be counting those as endochondral. But your thigh bones are. Articulation, when structures join together. Articulation is basically going to mean where your bones are able to move around at your joints. So here we have an elbow. Over here we have a knee. Your joints are able to articulate. You may know this word from English class, right? If they say someone is very articulate, it means that they are able to move their words around very well. Well, articulation in your bones means you're able to move your bones around very well. And articular cartilage. That's right, going back to articulation, in those joints that are moving, things rub against each other. It has a lot of friction. Bones get worn down, and we don't want that. So we have articular cartilage. Hyaline cartilage, more hyaline cartilage, guys, notice that? Hyaline cartilage that cover the end of bones at synovial joints. You may recognize the word synovial joints. We talked about that in the skin and membrane chapter, last chapter, where your joints all have the synovial membrane and synovial fluid water balloon for protection there. Right? In those areas, you also have hyaline cartilage as another layer of protection. That's going to prevent your bones from scraping past each other and wearing down to the marrow. which is very difficult to repair if that happens. Lever. Why would I be talking about levers? Didn't you learn about that in physical science or middle school? Why would I be talking about that in anatomy and physiology? Because your bones actually are levers. Right? Simple physics happening in your body. A lever is a simple machine that consists of a rod, fulcrum, weight, and an applied force. What are those things? A rod, look at this guy down here, is the stick, the actual lever itself. In your body, that would be your bones. A fulcrum is a pivot point, a place where they're going to bend around. So look over here at this picture, the bones of your skull you can actually see some of it right here and right here. Right? That would be the rod, and the fulcrum would be your neck, where your skull bobs up and down around those neck bones. A weight would be whatever force you're lifting. In this case, your face. Your face is sticking out forward a little bit, adding a little extra weight due to gravity. And an applied force. You have to use the bones, or in this case, the lever, to lift that weight up. And that is going to come from your muscle structures. So all of that together counts as a lever. And that's what's happening in your skeletal system. That's what's going to provide movement. The next couple words, 7, 8, 9, 10, 11, 12, 13, and 14 are all going to be different bone structures. Right? We are going to go into detail about different bones in the notes. For right now, we're going to be talking about parts of a bone. And this is going to be parts of an endochondral bone, your third word on this list, right? The long, skinny bones. And some of them are going to work for intramembranous as well. Periosteum is a fibrous covering of the bone. If you take a look at this bone right here, it looks like skin is being peeled off. That's weird. Your bones don't have skin. No, this isn't skin. This is a fibrous covering. Kind of like the fibers of your shirt. If you look at your shirt really closely, hold it up in a light, and you can see light coming through the fibers of your shirt. And that's what this is made out of, biological fibers, connective tissue fibers. And they are wrapping around your bone. Why is that important? Because that's how your tendons and ligaments attach to your bones. You remember, tendons and ligaments themselves are connective tissue fibers. So the fibers of your tendons are weaving into the fibers of your periosteum. And that's how they're going to connect, kind of like the weave that you would put in your hair. It's called that because it gets woven into your hair strands, and that weaving of the fibers is what keeps it held in your hair. The weaving of the fibers is going to keep your tendons attached to your bone, or your ligaments attached to your bones. And yes, just like when you pull on a weave, they can come out. If you pull on a tendon or a ligament too strong, it can come out, and it's very painful. Compact bone, densely packed bone tissue. Guys, we're actually going to have different kinds of bone material, 2 different kinds actually. If you look here where it looks like solid bone, that's called compact bone. And then number 9, spongy bone, you can see right here, it actually looks like a sponge. Guys, scientists are not clever when they try to name things. Remember, they have to remember these words too. They want to make it easy for themselves as well. So compact bone is just more compressed, compact. And spongy bone looks like a sponge. Tissue that is thinly packed and full of spaces. Number 10, epiphysis, the end of a bone that is shaped to fit a joint. Right here, this is the end of a bone. No, it is not a structure. All right, this piece of bone is not called an epiphysis. An epiphysis is a location. This location has a bunch of structures. This epiphysis location has compact bone and some spongy bone. You see it up here. We have another one up here. It has compact bone, it has spongy bone, it has articular cartilage, right? And it has this knob shape that is designed for the joint it's going to be a part of. This particular epiphysis is shaped to fit your shoulder joint. And down here, this epiphysis is shaped to fit your elbow. Diaphysis, the shaft of a bone. Again, this is not a physical structure. It is a location. It is the shaft in between the two epiphyses. So this whole area that includes the compact bone here, and there is spongy bone inside here, and the bone marrow right here, and the blood vessels here, this whole area is the diaphysis. So each endochondral bone is going to have two epiphyses and one diaphysis. Number 12, medullary cavity, the hollow space inside the diaphysis. That's right, guys, your bones are hollow. Did you know that? If your bones were fully solid, you'd be way too heavy. Your bones are actually hollow, and inside that hollow space, we fill it with marrow. And you have two different kinds of marrow, and those are going to be your next two vocab words. We got this yellow color marrow right here in the diaphysis. It's mostly fat. And you're going to have a red color marrow here in the spongy bone of the epiphysis. That's red because that's where blood is made. So let's take a look at those two vocab words. Red marrow, the tissue inside the spaces of the spongy bone, which produces blood cells. So you guys, turns out your red blood cells do not have nuclei. And if you remember Bio 1, you need a nucleus to go through mitosis. That's what mitosis is all about. No nucleus, no reproduction. Your blood cells cannot make new blood cells. So we need your bone marrow to develop new blood cells. And then yellow marrow, the tissue inside the medullary cavity, which stores fat. Because fat, come back up here, is all about storage. And we're going to store a whole bunch of calcium inside this fat because your bones are made of calcium. When you need to make new bone, it doesn't have to go too far to find its calcium storage. And then you use that to repair or grow your bones. And that is it for the vocab words. Guys, if you missed out on any of this, if I went too fast for you, you can feel free to rewind. If I posted this on a website right now where you can't rewind because it's forcing you to answer questions, then fear not. I have this on a YouTube channel as well where you can go back and forth as many times as you want, and that YouTube channel should be linked in Google Classroom. So go to Google Classroom right now, see if I left you any work to do, and I will see you in the next video.